Hello everyone, welcome to Infinity Learn by Sri Chaitanya. In this session, we will discuss LTC MPL Physics paper Weekend Test 70. So let's start with question number 1. We have airplane which is moving towards north horizontally with speed 200 meter per second and vertical component of the Earth's magnetic field is 0.5 into 10 power minus 4 Tesla. Induced EMF setup is, so E is equals to BVL and that is equals to 200 into B is 0.5 into 10 power minus 4 into L is 10. So after solving this value, you will get correct answer as option 1. Second is, a wire is sliding on two parallel conducting rails placed at a separation of 1 meter as shown in the figure. Magnetic field is 2 Tesla and it is perpendicular to the plane of the wire. What force is necessary to keep the wire moving with a constant velocity of 1 centimeter per second? So force over here will be V square L square V upon R. So B is 2 into 2, L is 1 into 1, V is 1 upon 100 divided by R is 50. So this will be 2 into 2. So this will be 80 to 10 power minus 4 times Newton. So correct answer is option 4. Next question is question number 3. A wheel with 20 metallic spokes, each of value 1 meter long, is rotated with speed 120 rpm in a plane perpendicular to the magnetic field. Okay. So magnetic field is 0.4 into 10 power minus 4 Tesla and omega over here is 120 rpm. So this is revolution per minute. So this is 2 pi into revolution per minute divided by 60. So this is omega. So induced EMF will be B omega L square by 2. Okay. So by putting the value of B omega L, everything in this expression, you'll get the value of induced EMF as option 2. Question number 4, we have thin semicircular ring of PQR, radius R over here and it is like this. So this effective length between P and R will be what? 2R. So induced EMF will be VBL but L is equals to 2R over here. So induced EMF will be 2R into VB and R will be at higher potential. So correct answer is option 4. Next is question number 5. We have coil of this much area turns and omega will be calculated using number of revolutions per second into 2 pi and field is 0.05 Tesla. So the maximum value of EMF developed is NBA omega. So put all these values to get the value of maximum EMF developed, which is option 3. Question number 6, the phase difference between the flux and induced EMF. So phi over here is BA cos theta and induced EMF is minus of d phi by dt, which is minus of BA sin theta. So you can write it as BA cos 90 minus theta, right? So over here you can see that phase difference will be theta and 90 minus theta. So phase difference will be 90 degree, which is pi by 2. So correct answer is option 2. Next is question number 7. Magnetic flux is, okay. We need to find the amount of charge. So delta Q over here is delta phi divided by R. So it is 60 minus 10, that is 50 divided by R is 100. So 0.5 coulomb is the charge induced in the circuit. Question 8. Flux is varying with time given like this and resistance is 10 ohm. We need to find the current at 1 by 4 second. So induced EMF is minus d phi by dt, which is 12t minus phi with minus sign. So current is induced EMF divided by resistance. So at 1 by 4 second induced EMF is 12 into 1 by 4 minus phi, that is minus of minus 2. So induced EMF is 2 volts. So current will be 2 divided by 10, which is 0.2 ampere. So correct answer is option 4. Question number 9. Current changes from plus 2 to minus 2 in 0.05 second. EMF is 8 volt. Coefficient of self-induction is. So over here, di by dt is equals to induced EMF. So L is unknown. Di is 2 minus 2. Basically, this is minus L di by dt. So it will be minus of minus 4 over here. Dt is 0.05 and that is equals to 8. So after solving this one, you will get coefficient of self-inductance as 0.1 Henry. Question number 10. Mutual inductance is 1.25 Henry and current di by dt is 80 ampere per second, rate of change of current, then induced EMF is, so it is M di by dt, which is 1.25 into 80, and that is option 4. Question number 11. The self-inductance of a straight conductor is, straight conductor has 0 number of turns and self-inductance is directly proportional to number of turns. So self-inductance of a straight conductor is 0. Question number 12. 50 millihenry coil carries a current of 2 ampere. The energy stored is, so energy stored is half Li square. So by putting this values, you will get energy stored, that is 0.1 joules. Question number 13. The magnetic potential energy stored in a certain inductor is this much. The current in the inductor is this. The inductor of the inductance is. So energy is half Li square. So L will be 2E divided by I square. So by putting the value of E and I, you will get the value of self-inductance over here. That is option 4. Question number 14. Which of the following quantity remains constant for a charged particle moving inside a magnetic field? So when a charged particle is moving inside the magnetic field, work done by the magnetic field on the charged particle is 0. So over here, velocity of the particle will change, but its kinetic energy will remain constant because of 0 work done. Question number 15. The magnitude of magnetic field at a point having perpendicular distance from a, okay. So magnetic field is given as mu naught I upon 2 pi r for a straight wire. R is 50 millimeter and I is 3 ampere. So put this value and divide this value by to get the answer in Gauss. So over here answer will be 0.12 Gauss. Okay. I hope this is clear so far. So in order to get the answer in Gauss, you'll have to divide it by 10 power minus 4. Okay. You'll get this answer in Tesla. Divided by 10 power minus 4, you'll get your answer in Gauss. Question number 16. Galvanometer has resistance 50 ohm and has 25 divisions, and current per division is 4 into 10 power minus 4. So Ig will be number of divisions into current for one division, which is 10 power minus 2 ampere, and we need to add one resistance to convert it into voltmeter of range 25 volts. So we know that R is equals to V upon Ig minus G. So V as 25, Ig is 10 power minus 2 and G is 50. So after putting all these values, you'll get resistance in series as 2450 ohm, which is option 4. Question number 17. We need to find total magnetic induction for this configuration. So we have for R1, it is into the plane, which is mu naught I upon 4R1. For R2, it is again into the plane, so it is mu naught I upon 4R2. So total will be addition of this 2 and the correct answer will be option 3. Question number 18. Current of 10 and 2 ampere pass through two parallel wires in opposite direction. Okay? And wire is infinitely long and wire B is of 2 meter long. Okay? And we need to find the force on conductor B due to E, and separation is 10 centimeter. So force is mu naught I1 I2 into L upon 2 pi D. So it will be mu naught which is 4 pi into 10 power minus 7. I1 is 10, I2 is 2, L is 2 divided by 2 pi D is 0.1. So after solving this one, you'll get the force as 8 into 10 power minus 5 Newton. Next case is question number 90. A current carrying loop is free to turn in a uniform magnetic field. The loop is will then reach equilibrium when its plane is inclined. So when plane is inclined like this, then this is area vector and this is magnetic field vector, and plane is inclined at 90 degree to the direction of the field. Then angle between area vector and magnetic field vector will be 0 degree, and in this case torque, which is mv sin theta, will be 0 because theta will be 0. So this will be the equilibrium condition. So correct answer is option 3. Question number 20. We have 50 turn circular coil of radius 2 cm carrying current 5 ampere is rotated in a magnetic field of strength 0.2 Tesla. In a particular position of the coil, the torque acting is half of the maximum torque, Tm, which is mv sin theta, and that is equals to mv by 2. So basically over here sin theta will be 1 by 2. So theta is 30 degree. But this is the angle between area vector and magnetic field vector, which is 30 degree. So angle between the coil and magnetic field direction is 60 degree. So correct answer is option 1. Question number 21. The magnetic induction at a point on the surface of a long straight carrying current is 12 microtesla. The magnetic induction at a distance t 3r from the surface is. So we have I current, and at this point at a distance r, magnetic induction is 12 microtesla. At a distance 3r from this point, we need to find new magnetic induction. So total separation will become 4r. So this is equal to mu naught I upon 2 pi r. Now new magnetic field will be mu naught I upon 2 pi into 4r, which is equals to 1 by 4 times of 12 microtesla. So new value will be 3 microtesla, which is option 2. Question number 22. A current flows in a conductor from east to west direction like this, and at the point above, what will be the direction of the magnetic field? So using right hand rule, so you can use this one, direction of current, then curl your fingers. So it is like this, so it is towards north. So correct answer is option 1. Question number 23. The velocity of an electron in the first orbit of hydrogen atom is v. Okay. The velocity of an electron in the second orbit of helium atom. So in the first orbit of hydrogen atom, we have velocity as v. So velocity in the orbit is directly proportional to z upon n. So for helium, z is 2 and n is again 2. So 2 will cancel each other. So again velocity in the second orbit of helium plus atom is nothing but what? Helium plus ion is nothing but what? V only, which is option 2. Question number 24. Total energy of an electron in the ground state of hydrogen atom is this one. Potential energy of electron in the ground state of lithium 2 plus ion will be. So this is total energy, and potential energy is 2 times total energy. So it is 2 into minus of 13.6, which is 27.2 electron volt with minus. Now total energy is directly proportional to n square. This is for hydrogen. For lithium plus 2, it will be 3 square times of minus 27.2 electron volt, and that is equal to minus 244.8 electron volt. Question number 25. How does the binding energy per nucleon vary with the increase in the number of nucleons? So it is very simple fact based question. First it increases, then decreases with increase in mass number. So correct answer is option 3. Question number 26. The ratio of radii of the nuclei of this to this is. So radii is directly proportional to a power 1 by 3. So R1 upon R2 over here will be 27 upon 125 power 1 by 3, which is 3 upon 5. So correct answer is option 4. Next is question number 27. The binding energy per nucleon for C12 is this much and for C13 is this much. The energy required to remove a neutron from C13 is. So energy required will be 13 times 7.47 minus this will be 12 times 7.68. So after solving this one, you will get energy required as 4.95 mega electron volt. Question number 28. Mass number A increases, the quantity related to the nucleus does not changes. So density is independent of the mass number, so it will remain same. Next is question number 29. A ball is thrown vertically downwards from a height of 20 meter with initial velocity v0. It collides with ground. Okay, so let's say it collides with velocity v, and let's apply conservation of energy for this one. So over here, half mv square minus half mv naught square, there is loss in kinetic energy. Gain in kinetic energy is equals to loss in potential energy, which is mgh. Now when it rebounds, it loses half of its kinetic energy. So 50% of half mv square will be half of half mv square, and that is equal to again gain in potential energy, that is mgh. So over here mgh is 1 by 4 mv square, so it is half mv square minus half mv naught square is equals to 1 by 4 mv square. M cancel, so we have half of v naught square is equals to v square by 2 minus 1 by 4 v square. So v naught square by 2 is v square by 4, and this is v square by 2. So v naught square is v square by 2, but v square by 2 over here is 2gh. So this is 2gh 4gh divided by 2. right? V square is 4gh, so this 4gh divided by 2, that is 2gh. So V naught over here will be under root 2gh only. So put the value of g as 10 and h as 20. So you get your V naught as 20 meter per second. Question number 13. Particle moves from this point to this point. So R vector will be 4j cap plus 3k cap minus of minus 2i cap plus 5j cap. So R vector will be 2i cap minus j cap plus 3k cap, and F vector is this one. So work done will be F dot R. So it will be 4 into 2, 8 plus 3 into minus 1 minus 3 plus 0 into 3, 0. That is 5 joules. So work done over here will be 5 joules. Question number 31. Force is given and we need to find the work done in moving it from 1 to 2. So force work done will be integration of dx, which is 2 plus x dx, and that is from 1 to 2. So this is 2x plus x square by 2, and that is from 1 to 2. So after solving this one, you will get work done as 3.5 joule, which is option 1. Question number 32. Work done by the force of friction in moving a body around a closed loop is 0. No, it is non-conservative force, so it will not be 0. Work done does not depend upon the nature of force. It does depend on the nature of the force. So both of these statements are wrong. So correct answer is option 4. Question number 33. A spring of force, this constant has initial stretch of 0.2 meter and final is 0.25 meter. Increase in potential energy. So it will be half k x2 square minus half k x1 square. Put the value of k as 10, x1 as 0.2 and x2 is 0.25, and you'll get change in potential energy as 0.1 joule. Question number 34. A uniform rope of length L and linear density mu is on a smooth horizontal table with length L lying on the table and remaining length, which is L minus L, is hanging. The work done in pulling the hanging part onto the table is, so work done is equals to what? Mgh over here. So this will be center of mass. So this length is L minus L by 2. So we need to pull from L minus L by 2 to L by 2 to 0 level, right? So over here, work done will be mass of this length, which is mu into L minus small l into g into length required from center of mass. This is this much. So this is mu g L minus L whole square divided by 2, which is option 1. Question number 35. A body is projected vertically up with certain velocity. So its entire kinetic energy is nothing but mechanical energy. At a certain point, potential and kinetic are in the ratio of 9:16. So potential upon kinetic is 9/16, but we know that potential plus kinetic is equals to mechanical energy, which is half mv square, right? That is initial kinetic energy over here, right? So over here, if you look at it, so kinetic energy, let's say at this point, is k. So potential will be 9/16 times k. So it is 9/16 k plus k is equals to half mv square, right? So this will be 25/16 k, that is half mv square. So k at this location is 16/25 into half mv square. Let's say at this location velocity is v dash, right? So new kinetic energy is half mv dash square is equals to 16/25 half mv square. Cancel, half cancel, so we have v dash square divided by v square is 16/25, and v dash upon v will be 4/5. So ratio of v to v dash will be 5/4, which is option 2. Question number 36. We need to find the power sent in the process over here. So it is v square L square v square upon r. V is given as 1, L is given as 1, v is given as 20, and r is given as 0.2. So after solving this one, power sent to the resistor over here will be 2 kilowatt, which is option 2. Question number 37. A uniform magnetic field is existing and length is along y-axis, velocity is along x-axis. So induced EMF in the rod is, so induced EMF is VVL, where VVL, all of these three quantities are mutually perpendicular to each other. So only perpendicular component which is perpendicular to length as well as velocity is the component which is along z-axis. So phi Tesla is responsible for producing EMF over here. So this will be phi into 1, that is 25 volt. Question number 38, we have this network shown in the figure. We need to find VB minus VA. So this will be current direction. So this is positive, negative, positive, negative, positive, negative. So VB minus VA. So we are moving from VB, that minus phi L di by dt. So this is phi into 10 power minus 3. Di by dt is 3. 10 power 3 plus 12. Sorry, this will be plus. We are moving from negative to positive, and again plus 4 into 1, that is VA. So over here, VB minus VA will be minus 21 volt, which is option 3. Question number 39. A small square loop of wire of length L is placed inside a large square loop of side capital L. Okay. The loops are coplanar and their center coincides. The mutual inductance of the system is proportional to. So over here, mutual inductance will be dependent on the magnetic field generated and area, right? So area of smaller loop will be L square. So mutual inductance is directly proportional to L square, and magnetic field generated because of this one is inversely proportional to capital L. So mutual inductance will be directly proportional to small l square divided by capital L, which is option 2. Question number 40. A long solenoid has 50 centimeter length having 100 turns. So number of turns per unit length is 100 divided by 0.5, that is 200 turns. Magnetic field is mu naught Ni. So N is 200, mu naught is 4 pi into 10 power minus 7 and I is 2.5 ampere. So after putting all this value, magnetic field will be option 4. Question number 41. A wire of length L meter carries a current of I ampere. It is buoyant in the form of circle. So radius of the wire over here is 2 pi r is equals to length. So r is L upon 2 pi. So area is pi r square, which is pi into L square upon 4 pi square, which is pi L square upon 4 pi. So magnetic moment is I into A, which is I pi L square divided by, sorry, this pi will cancel this pi. So I L square divided by 4 pi. So correct answer is option 1. Next is question number 42. We have toroidal solenoid with 100 turns and mean radius is 4 centimeter. The current in the winding that is required to set up a magnetic field of this one is, so magnetic field is mu naught Ni upon 2 pi r. Okay, so this is the magnetic field due to this toroidal solenoid over here. So again, bacho, this is 4 into 10 power minus 3, mu naught is 4 pi into 10 power minus 7. N is 400, I is unknown, and divided by 2 pi into R is 4 into 10 power minus 2. So after solving this one, you will get the current value as 2 ampere. Question number 43. A galvanometer coil has a resistance of 80 ohm and the permissible current through the coil is 10 milliampere. What should be the shunt resistance that should be used to convert this galvanometer into ammeter? Okay. So over here, this is shunt resistance and this is galvanometer branch, and this is 80. Permissible current is 10 milliampere. So remaining current 10 minus 10 milliampere will pass through the shunt resistor. So we know that I G into G is equals to I minus Ig into S. So shunt over here will be Ig into G divided by I minus Ig into S. So this will be 10 into 10 power minus 3, G is 80 divided by 10 minus 10 power minus 2 into, sorry, not S only, this one only. So this is the shunt, and after solving this one, you'll get the value as 0.08 ohm. Question number 44. In the circuit shown in the figure, the ring is made of wire of uniform cross section. If magnetic induction in the center O is produced by segment ACB is 25 microtesla, what will be the magnetic induction at O produced by segment ADB? So these two segments will produce equal and opposite magnetic fields because of their distribution of the current, right, and the angle made. So over here, net magnetic field should be 0. So if it is producing 25 microtesla, it should also produce 25 microtesla in the opposite direction. So correct answer will be option 4. Question number 45. An electron moving in a circular orbit of radius r makes n rotations per second. So current I over here will be Q into frequency. So it is E into N over here. Magnetic field induced at the center has magnitude. So B is mu naught I upon 2R. So it is mu naught Ne upon 2R, and that is equal to option 2. Question number 46. If L be the orbital angular momentum of the hydrogen atom, okay, which is nh upon 2 pi, and r be the radius of the atom, then which of the following relation is correct? So r is equals to what? R naught into n square. So over here, instead of writing n square, we can write 2 pi L divided by h as n. So it is r is equals to r naught into 2 pi L divided by h whole square, which is r naught 4 pi square L square divided by h square. So you can see that L square is r h square divided by r naught 4 pi square. Okay. So L square is directly proportional to r. So L is directly proportional to under root r. So correct answer is option 4. Question number 47. The mass of neutron and proton are this much and this much. If 2 protons and 2 neutrons from the nucleus of helium whose mass is this, then find the binding energy. So binding energy over here will be 2 times 1.0087 plus 1.0073 minus 4.0015 AMU into 931.5 mega electron volt. So after solving this one, you'll get binding energy as 28.4 mega electron volt. That is delta M into 931.5 mega electron volt. Question number 48. A car and a truck are moving with same kinetic energy. Okay. To stop them, brakes exerting equal forces are applied simultaneously. Then which of the following statements is correct? So car and truck are moving with same kinetic energy. So final momentum will be 0. Initial momentum V is under root 2 mk. Mass of the truck will be more than the mass of the car. So momentum of the truck will be momentum greater than momentum of the car. So change in momentum will produce force. Right. So force is equal. So time over here will be force is delta P upon delta T. So delta T will be delta P upon force. Change in momentum will be more for truck as compared to car. So delta T is delta P upon F. So change in momentum is more for truck with the same amount of force. Then time required by the truck to stop will be more. Right. So car will stop earlier, but truck will stop after some time. Although this too will cover the same value of distance before coming to rest. Question number 49. The potential energy of a particle in a force field is this one, and we need to find the equilibrium position. So F is equals to minus du by dr, and it should be 0 at equilibrium position. That means du by dr should be 0. So over here, A r power minus 2 minus B times r power minus 1 is u. So put the value of du by dr is equals to 0 over here. So du by dr in this case will be A times minus 2 r power minus 3 minus B times minus 1 r power minus 2 is equals to 0. Right. So this is minus 2A upon r cube plus b upon r square, and it should be 0. Matlab 2a upon r cube is equals to b upon r square. So either r is 0 or r is equal to 2a upon b. So this is the equilibrium condition, which is option 4. Question number 50. A particle of mass 0.1 kilogram is subjected to a force which varies with distance as shown in the figure over here, right? It starts its journey from rest at x is equals to 0. Its velocity at x is equals to 12 meter is. So over here we have work done as area under force displacement time. So this is half into, this is 12 and this is 4, 16 into 10. So this will be 80, right? So this is work done. Now particle is starting from rest. So this work done is equals to change in kinetic energy, that is just half mv square. So this will be 80 is equals to half m is 0.1 into v square over here. So v square is 160 divided by 0.1. So v square is 1600. So v will be 40 meter per second, which is option 4.